At the point when we contemplate stars, we frequently envision little shimmering focuses in the evening sky. This is the manner by which we see them from Earth. Anyway, stars like Betelgeuse are totally divergent. Truth be told, Betelgeuse is tremendous to such an extent that it is far larger than our Sun. For quite a while, this star, however, has bewildered researchers. As of late, something significantly more disrupting has been occurring with Betelgeuse, causing worry among scientists and specialists the same. In this video, we dive into the frightening updates regarding Betelgeuse, including its anticipated destruction as gauged by the James Webb Space Telescope. We'll likewise investigate how these advancements could affect our cosmic system and life on Earth, as made sense of by physicist Michio Kaku. Betelgeuse is a spellbinding miracle, an enormous star that has fascinated stargazers for a long time. The first revelation of this star came from the Greek cosmologist Ptolemy. This star is so colossal that it very well may be seen in the evening sky from Earth, especially throughout the cold weather months. In the event that you have a passion for space science, you've likely seen or caught wind of it. Betelgeuse is the dazzling rosy-orange star that marks the upper left shoulder of the Orion constellation. It's an old star, one of the most iridescent in the evening sky. Anyway, its splendor isn't steady, and it changes. This inconstancy is one of the intriguing qualities of Betelgeuse, yet it's not the only exceptional feature. Most of the stars we see around evening time are amazingly far off from our planet. The closest one, Proxima Centauri, is found 4.2 light-years away. Assuming you're uncertain how the term light-year connects to distance, envision going at the speed of light for a whole year. It's been laid out that light goes at 186,000 miles per second, and the complete distance light covers in a year adds up to 1 light-year, which equals billions of miles. So, when we say Proxima Centauri is 4.2 light-years away, it implies that it is billions of miles from Earth. Yet, some stars, like Betelgeuse, are much further. Betelgeuse is roughly 600 light-years from Earth. This implies that if we could travel at the speed of light, it would take us 600 years to arrive. Tragically, we can't go at that speed, not even with our quickest spacecraft. Still, Betelgeuse sparkles brilliantly in our sky despite its perfect distance. In the event that you're considering how Betelgeuse can be so bright from so far away, the answer lies in its outstanding qualities, for example, its huge size and intrinsic glow. Betelgeuse is multiple times larger than the Sun, and its radius is believed to be several times that of the Sun. When seen with advanced telescopes, it appears as a disk rather than a small point of light, unlike most other stars. This peculiarity is thought to be caused by the reactions occurring in its outer layers. With respect to its mass, Betelgeuse weighs somewhere between 12 and 20 times the mass of the Sun. One solar mass is comparable to 2 times 10 superscript 3 kilograms. However, astronomers can't pinpoint the exact mass of Betelgeuse because there are no planets or bodies orbiting it for comparison, and measuring it directly is impossible from Earth. What makes Betelgeuse so astounding is that it is ordinarily more massive than our Sun. The star's brilliance ranges from a magnitude of +0 to +1.6. In simpler terms, Betelgeuse is 16,000 times more luminous than our Sun, earning it the nickname of a red giant. Anyway, its brilliance isn't consistent. It changes. This variety is brought about by the star's pulsations. When Betelgeuse expands, it becomes brighter, and when it contracts, it darkens. These cycles can last anywhere from 10 to 100 days or even longer. An intriguing aspect of Betelgeuse is that its surface contains dark magnetic spots, regions where the magnetic field is far stronger than the typical surface. These spots hinder the flow of hot gases to the surface, cooling those areas. Betelgeuse has far more of these spots compared to our Sun, which explains why it is cooler than the Sun despite its greater size and brightness. While our Sun also has dark magnetic spots, Betelgeuse's spots are much larger and more numerous. To give you a sense of scale, some of these spots can be twice as large as Earth. Betelgeuse also has a magnetic field that is 200 times stronger than the Sun's. This magnetic field is responsible for the twisting or arc-like patterns that appear on its surface when seen through a telescope. The surface temperature of Betelgeuse is around 3,500 Kelvin, which adds to its low energy output and faint red color. It wasn't always a red star, though. Around 40,000 years ago, Betelgeuse had a yellowish tone, similar to our sun. Over time, its color shifted to orange, then red, and around 10,000 years ago, it began changing into the red star we see today. This change led researchers to conclude that Betelgeuse is aging. Betelgeuse emits up to 100,000 times more energy than our sun. Had it been closer to Earth, it would have outshone our sun. If it were even slightly closer, we might have been able to see it during the day. Anyway, due to its huge size, if Betelgeuse replaced the sun, it would engulf Earth and the nearby planets. Even if Betelgeuse could somehow match the sun's energy output, it would still emit far more energy, making it even more powerful than our sun. Despite being 600 light-years away, Betelgeuse is still visible to the unaided eye, which is remarkable. Our sun is just 8.3 light-minutes from Earth, which is why it's so much brighter. Betelgeuse's current state has captured the attention of astronomers worldwide. Over the past few years, the star has exhibited unusual behavior, including a significant dimming event in late 2019 and early 2020, which was so pronounced that it became visible to the naked eye. This event, often referred to as the Great Dimming, sparked widespread speculation about the star's future, with some wondering if it was on the verge of a supernova explosion. Subsequent studies revealed that the dimming was caused by a combination of factors. One major contributor was a massive ejection of material from the star's surface, which formed a cloud of dust that temporarily obscured Betelgeuse's light. Additionally, cooling of the star's surface played a role in the dimming. These findings highlighted the complex and dynamic nature of Betelgeuse, as well as the challenges involved in studying stars of this magnitude and distance. Despite the resolution of the Great Dimming mystery, questions remain about Betelgeuse's long-term fate. As a red supergiant nearing the end of its life cycle, it is expected to undergo a supernova explosion within the next 100,000 years, a relatively short time in cosmic terms. When this happens, Betelgeuse will briefly outshine the entire galaxy, becoming as bright as a full moon and visible even during the day. The explosion will release vast amounts of energy and material into space, enriching the surrounding interstellar medium with elements essential for the formation of new stars and planets. Astronomers are closely monitoring Betelgeuse for signs of impending collapse. Key indicators include changes in its brightness, surface activity, and spectral lines, which provide clues about the processes occurring within the star. Advanced telescopes such as the James Webb Space Telescope and ground-based observatories are being used to gather detailed data on Betelgeuse. Betelgeuse, located in the Orion constellation, is one of the most significant stars we know. Its tremendous size, 700 times that of our Sun, is its most striking feature. If placed at the center of our solar system, Betelgeuse would easily include the orbit of Jupiter. This massive size causes Betelgeuse to appear as a disk when seen with powerful telescopes, unlike most stars, which appear as tiny points of light. Although it's not the most massive star in the universe, Betelgeuse's mass ranges from 12 to 20 times that of the Sun, depending on various estimates. One of the most fascinating aspects of Betelgeuse is its variability in brightness. Unlike the Sun, which remains relatively stable, Betelgeuse experiences irregular fluctuations in brightness. These fluctuations are believed to be the result of pulsations within the star. At its brightest, Betelgeuse is 16,000 times more luminous than the Sun. Yet, during its dimming episodes, its brightness can drop significantly. These variations have intrigued astronomers for decades and provide valuable insights into the star's life cycle and characteristics. Betelgeuse's surface temperature is relatively low for a star of its size, around 3,500 Kelvin, which gives it its reddish-orange color. As a red supergiant star nearing the end of its life cycle, Betelgeuse has depleted the hydrogen fuel in its core and is now fusing heavier elements. This fusion process generates energy and causes the star to expand. The star's surface is also marked by dark magnetic spots much larger than those found on the Sun, which restrict the flow of warm gas from the interior to the surface, leading to cooler regions. Betelgeuse has been studied for centuries by astronomers from various cultures, including the Greeks, Egyptians, and Chinese, who recorded its position and brightness. In Arabic cosmology, Betelgeuse is called Yad al-Jawza, meaning the hand of Orion, due to its prominent position in the constellation. Betelgeuse has been a subject of fascination for centuries, with its vivid red hue and prominent position in the Orion constellation capturing the imagination of cultures across the globe. Ancient astronomers observed its brightness and color changes, often attributing these characteristics to divine or supernatural forces. Today, modern science has provided a deeper understanding of the physical processes underlying these phenomena, revealing a star in the late stages of its life cycle, undergoing dramatic transformations. As a red supergiant, Betelgeuse is vastly different from our Sun. It has expanded to a size that would engulf the orbits of the inner planets if placed at the center of our solar system. This immense size is a result of the star exhausting the hydrogen in its core and beginning to fuse heavier elements. The energy produced by this fusion causes the outer layers to swell, creating the characteristic red color and relatively cool surface temperature of 3,500 Kelvin. These physical properties make Betelgeuse one of the most luminous stars visible from Earth, despite being 600 light-years away. The irregular brightness variations of Betelgeuse have long intrigued astronomers. Unlike the Sun, which maintains a stable luminosity, Betelgeuse exhibits periodic dimming and brightening cycles. These fluctuations are thought to result from pulsations in the star's outer layers, as well as the formation and dispersal of massive dust clouds. Observations of these variations provide valuable insights into the internal dynamics of red supergiants and the complex interactions between their magnetic fields, convection processes, and stellar winds. The prospect of Betelgeuse going supernova has sparked widespread interest, not only among scientists but also among the general public. A supernova explosion of this magnitude would be a rare and spectacular event, offering a unique opportunity to study the death of a massive star in unprecedented detail. The light from such an explosion would be visible for weeks or even months, illuminating the night sky and providing a cosmic spectacle unmatched in modern times. The remnants of the explosion would also play a crucial role in seeding the galaxy with heavy elements, contributing to the ongoing cycle of star and planet formation. While the exact timing of Betelgeuse's supernova remains uncertain, ongoing observations continue to refine our understanding of its behavior. The development of advanced technologies, such as high-resolution imaging and spectroscopy, has allowed astronomers to probe the star's surface and atmosphere with remarkable precision. These tools have revealed intricate details about the star's structure, including the presence of giant convection cells, magnetic activity, and the dynamics of its outer layers. The study of Betelgeuse extends beyond its immediate characteristics, offering broader insights into the life cycles of massive stars and their impact on the universe. By examining the processes occurring within Betelgeuse, scientists gain a deeper understanding of the mechanisms driving stellar evolution, the formation of supernovae, and the distribution of elements essential for life. These discoveries not only enhance our knowledge of the cosmos but also deepen our appreciation for the interconnectedness of all things in the universe. As Betelgeuse continues its journey toward its inevitable fate, it serves as a poignant reminder of the transient nature of even the most massive and luminous stars. Its story is a testament to the dynamic and ever-changing nature of the cosmos, where creation and destruction are inextricably linked in an endless cycle. Through the study of stars like Betelgeuse, humanity is drawn closer to understanding the profound mysteries of the universe and our place within it.